Um, so welcome to Net 303, Livin on the Edge. I actually wanted to have that song playing, but it was not to be. Just a quick reminder, please do fill out the dory if you have questions. That's how we will be intaking questions. Of course, there are microphones here if you want to have just a live Q&A. It'll really help us sort of record the questions and see what kinds of interests folks have in the field. And with that, let's go into introductions. So my name is Saurabh Gupta. I am a PM on Cloud CDN. And with me here is esteemed friend and colleague, Brian.
Hi. I'm Brian Rogan. I'm the Senior Director at Google for CDN and engineering for the internet-facing network, as well as interconnect. So I think I'm going to take it away from here and walk you through our agenda. We're going to talk a little bit about the background of Google CDN. I'll take you through a little bit about how it works under the hood and how we think about the content delivery problem at Google. Saurabh's going to take you through how to actually get everything up and running yourself. And then we'll talk a little bit about security and how you can use what we built to be successful in your business. So to start off, and I think one of the things that TK talked about a lot on Tuesday, all the way back when at the beginning, was about openness. And Google Cloud is about openness, and CDN at Google is no different. Well, today we're going to talk primarily about our first-party CDN offering. We work with a series of amazing CDN interconnect partners who can offer you preferential pricing on cash fill, so that at Google, you know you're going to have the CDN that satisfies your needs best. It's not about lock-in. It's not about kind of pushing you towards us. It's about the choice that works for you. To talk about where we see kind of Google CDN being different, first off, I think it comes down a lot to performance. That's kind of our headline. That's what we've been working on a lot at Google over the last decade in CDN, is how do we have the broadest reach, the deepest kind of connectivity, and great performance. And I think the numbers sort of speak for themselves here, both in terms of throughput and latency. So we think we really have a best-in-class product on CDN when you think about performance and you think about how to reach your users all over the globe. We think the product's also really marked by simplicity. Saurabh will take you through this in a lot more depth, but you can turn on CDN at Google with a single checkbox, and with that checkbox, you get all of our deployment. You get reach all around the world, and you get CDN. You get caching. And let's look at that reach. So we have 134 points of presence, and again, for the last north of a decade, we've been investing in our physical infrastructure and in the network that's going to get you around the world and get you close to your users. Again, we'll dive actually a fair bit deeper into this and how we think about this part of the problem. But along with that, you also get scale, and you get the infrastructure that Google uses for its own first-party services. And we have 7 products with over 1 billion users each, all around the world. And again, we'll dive a little bit deeper on how we think about that part of the problem. So to jump in a little bit and talk about our network architecture, I want to kind of reflect back on when we started this journey at Google. Then the year was 2006. We had just acquired YouTube, and at that time, if you could make it through a YouTube video without it rebuffering, it was like a small miracle. We kind of celebrate. I ruined many a Friday night social gathering by trying to watch YouTube with friends, popping out my TCP dump and grabbing logs when things didn't work. It was a super awkward experience for everyone involved. I was not invited back. But if you flash forward a decade, right, I think one of our greatest accomplishments is the fact that for the vast majority of users and for the vast majority of workloads now, connectivity blends into the background, right? I watched the Super Bowl on YouTube TV 5 seconds behind the Mez feed for 3 hours without a rebuffer, right? This year, right? And as a user, I didn't even think about that, right? I just assumed that would work, right? And so I think what we've seen over this time is like an absolutely transformative experience in terms of what it means to be on the receiving end of content delivery. And I think what that means for you, for our customers, is that all of a sudden you can build all of these amazing experiences where connectivity just gets out of the way, right? Where the users are not distracted by the fact that things are buffering. They're not distracted by waiting. They can really engage with your content, and they can really kind of work closely with your business. So I wanted to talk a little bit about how we think about the content delivery problem and what got us here, just to give you some background about what's underneath the hood of that single checkbox. So when we think about how to reach the globe, step one is kind of the obvious. You need to go where the users are. And so the main challenge of the content delivery problem is kind of content lives in data centers, and users live everywhere, right? And so the goal is to figure out how we can, with the best performance possible, get your content from our data centers directly into the last mile and to your users' devices and into their homes. And so first thing first, we go where the internet is. We work with anybody. We connect to the vast majority of networks of last mile, user-facing networks on the globe directly, and that's a point of pride of ours. And it's a core part of how we got here and how we built what we have. We run it at massive scale, at Google scale, and so again, the Cloud CDN product is a product that leverages all of the scale of the infrastructure that we've built at Google. And you kind of ride along, and you get that for free. And finally, and I'll talk a little bit about this, we've spent the last few years figuring out how can we innovate in the content delivery problem? How can we innovate in network? And how can we make it so that you really have a very unique set of capabilities here that push forward the whole internet? Just to go back again, and to talk about that content delivery problem, you know kind of where our data centers are. You also have a sense of kind of then all of our edge points of presence are places where we have CDN caching. And so I thought maybe it would be kind of cool to take you through a little bit of the journey of how your content starts at a data center and how it gets out to the internet. So I figured I would start with this beautiful slide of one of our data centers at Sunrise. And well, it is gorgeous, and I would love to be there. You will notice there are not a great many users there. And so that's sort of one of the central challenges, right, of that in general. Data centers on the internet are placed in places where you can acquire, a couple hundred acres and like a gigawatt of power, right? Not necessarily right in the middle of kind of city centers. And I think this is an important kind of insight, because if you think about how the internet is provisioned, right, how the internet works, it's all around kind of the centers of population. It's all around the places that you'd want to go out on a Friday night, right? The New Yorks and Londons and Parises of the world, right? And so there's quite a journey to sometimes be had from where your content lives to where your users are. So it starts at the data centers, right? But at Google, and I think compared to some other people, content delivery is a ground-up problem for us, right? And we literally think about it as how do we get from where your content lives, from where your workloads live, all the way through to the internet. And so here we have some pictures of some of the construction. This is all first-party stuff that we've done at Google. And up on the top left, which I think is really cool, is us burying duck bank. And you'll see there's a whole bunch of conduits, and they actually get strung together in a metal frame to make that cool square. And then we didn't show the part where they fill the whole thing in with concrete, like miles and miles and miles of concrete. So I mean, just think that in this world, right? This is an intensely physical process, right? That's one of the things I like to kind of remark about in CDN, right? Is that for most people, the internet is this very ethereal thing. It kind of lives off in the cloud, right? But in our world, I mean, it's concrete and conduit and pulling fiber, right? And it is a very physical thing. On the bottom right, you have a little bit more of an easier kind of long-haul pull with a little bit less fiber, where we actually just do kind of open trenching that we cover in. But again, these are the kinds of physical investments that power this network that you see. Obviously, we have significant subsea investments, 13 subsea investments that we've done either through consortia or with other folks. And if you've never seen how submarine cable is laid, it is one of the most mind-blowing things that I have seen in my life. I mean, we have a gigantic cable ship that literally runs cable across the entire ocean, lays it down on the ocean floor through kind of valleys and ridges, trying to figure out how we can make sure that we have a clean path underneath the ocean. But the craziest part is it's not just passive, right? Like all of this light needs to be repeated every 100 kilometers or so. And so there's literally active equipment that lives underwater. And when these things break or when they need to be fixed, right, we send UAVs down and pull the cable up, and the cable tents for miles, right, because of trigonometry. So these are these kind of just absolutely amazing things that happen under the hood, all kind of sight unseen to you, the user of our service. Then when we talk about, OK, what does it mean to meet the internet where it is, right? The internet is all around the world. And so this is actually what maybe one of our 134 POPs looks like, right? And you'll notice, compared to the next slide, everything here is very clean and cabled. But in the bottom right, this is actually what one of our peer-facing fabrics looks like, right? Just cabled up. And the thing that you have to keep in mind, again, it's just the scale, right? Like these are sort of 2 routers that are part of the fabric in one of the 134 POPs, right? And so this is just a massive, massive globally distributed infrastructure, and with just hundreds of thousands of pairs of fiber, all of them meticulously labeled, you'll note, which is, I don't know how anyone has the patience to do that, but I thank them for it. And so that's kind of what the physical infrastructure looks like on the ground. And all of that is to actually meet the internet, right? And so you'll notice now we're kind of outside of space that's controlled by Google, but when you think about how the internet actually works in the real world, right, it's literally about 2 different networks connecting to one another physically, right? And so we're actually creating an optical path between, say, Google and a network that can help us deliver that content. And it's sometimes a messy business. This is a meet me room at one of our co-location facilities, where basically networks that connect to user traffic and Google will actually meet up, make a fiber path, and kind of link back to our infrastructure. So this is sort of the messy business of how the internet works under the hood. And I think just to talk a little bit about, this is the result, is kind of what you see with Google Network Tiers, right? This is the premium network that we keep talking about and what it means, right? Where you can actually ride our first-party infrastructure right from your data center all the way to the end user. We also offer for more kind of value-minded customers or for workloads that don't necessarily need the performance of that premium tier, a standard tier product which rides over the internet and doesn't necessarily get to take advantage of all of that privately built infrastructure. But you can see the difference, right? Like when we look at what does it mean to be on that premium network, in this particular test, we can actually see an almost 2x improvement in throughput, right? And so those ground-up investments, right, really, really matter, right? And again, I think that's for me the main takeaway here, right? Is that when you come to Google, you have an infrastructure that's built literally from the dirt, right, up to give you the best performance, and you can see it. I want to talk a little bit about, too, what we were busy doing on the software side for that decade to get us there, right? And here we also, I think, had a lot of really interesting innovations over that time. One of the areas that we've worked a lot in, because there's such high leverage, is the area of transport. So the protocols that actually make sure we can reliably deliver traffic over the internet. So Quick is something we've invested a lot of energy in over time. It originated here, although it's an open standard, used by many people. And we worked a lot on how do we get latency down, and so we have the zero RTT handshake that allows you to kind of quickly establish a connection to Google. And you can see what it meant to us. Like when we flipped on Quick en masse, we saw a significant improvement in throughput across the board. And so I think this has been really like one of the key drivers of sort of innovation at the protocol level for us. We also worked a lot on congestion control, and that was agnostic to TCP and Quick. Both implement a congestion avoidance protocol that we call BBR, and that works on the insight that whereas classic, TCP cubic, for example, will back off when it notices loss in the network. BBR uses the insight that in a modern network, the routers have very deep buffers. And so you can actually tell that things are starting to get full by noticing the packets space out more and more. And you can use that as a signal that the network's congested and back off. And it turns out, in the modern internet, for many use cases, it's actually a much more reliable signal of the available throughput on a link. And so what we can actually see here is that when we use BBR, we can achieve significantly higher throughput in the presence of the kind of sporadic loss that happens on the internet over the same RTT. And so those were kind of 2 things that I wanted to dive deeper on. But again, I think it's important to know at Google that innovation in the network is something that we have been doing consistently over the last decade. A couple of things that are particularly cool for CDN are our Google Global Cache deployments that live all around the world. Espresso, which is our internet-facing software-defined networking stack. And so if you can imagine, in real time, one of the things that we do is we figure out exactly how traffic is going to flow across that network that Google operates and how it's going to flow through the internet. We try to make sure that we never overload any link. We monitor in real time, again, all in software, every minute, to see where there's any degradations in performance to certain parts of the internet, and how we can use that broad footprint to route traffic around it. And so this also, I think, has been one of the key things, this proprietary traffic management system, that has enabled us to really push the bar and make things better at Google. So with that, I wanted to hand it over to see, OK, we have this amazing infrastructure, or so we'd like to think. And how do you actually set it up, and how do you get all that simplicity?
Cool. Thank you.
All right.
So setup and use. How do you get started? How do you make this work for you? So let's take a look at that. first, we'll start by seeing what a traditional CDN looks like and how it thinks of the world. You will start with there's actually a gray box around here. So use your imaginations. There is a gray box, which is a regional data center. And in that, you have some kind of virtual machine or some kind of an object store, which is fronted by a load balancer, which is then fronted by a regional IP. That regional IP is advertised through the regional public network. And that's why if you have sort of multi-region deployments, you will then have that same deployment across different data centers. Each one will have their own load balancer. Each one will have their own sort of regional IP. And then they will plug into the public network that is proximal to that data center. Which means you really need to layer a wrapper of caching around all this, right? So you will then have a separate layer of caching that exists at the edge, which means if a user, let's say in LA, wants to connect to your content, they will do, if they're using your domain name, they will look up some kind of DNS entry. They will find the IP that creates a path to your cache endpoint. And then also the caching infrastructure will need to know where to get that data from. So at some level, they will have to back into the public network again, go through that public IP, find the load balancer, et cetera, and serve that content back out the same path. So really, there's lots of hops. This is going through the public network. This is going through the public network, right? And also at the edge, you have a fair amount of complexity in configuration in terms of IP-based load balancing or DNS-based load balancing, et cetera. So this is kind of like a summary, right? Multiple DNS lookups. CDN is a separate system from your serving infrastructure, regional constructs with, again, regional IPs. If you look at how Google approached it, we said, let's, again, because we have that, again, global construct to our VPCs, our load balancers actually sit at the edge, right? They're not, I mean, part of their infrastructure is at the edge itself. And this is our Google Fiber that Brian gave you a preview on. So when you have to get data out of Google, you have a global Anycast IP, so it's broadcast out of all these endpoints, and you can figure out the fastest path to that endpoint. You then ingress at the edge location. The load balancer figures out how to route the traffic efficiently through the backbone to where the data is actually stored. You traverse this private fiber path. Again, also to the private, you traverse this private fiber path to the correct data center. You get your data, and you then traverse that back out. So what you get are distributed constructs all the way through, right? You get distributed load balancing, distributed caching, and distributed SSL at the edge. There's another cool thing that happens here. So the SSL will be advertised out of this endpoint. So your front end will have your domain-based SSL. And let's say you say, you know what, I want this to simply serve HTTP to my load balancer front end. That will still be an encrypted transit path. Google's just going to encrypt that in transit, so you don't have to explicitly create an SSL infrastructure to have this edge traffic reach here. You obviously can. You can have self-signed keys. You can have all those types of things. But in general, by putting SSL at the edge, you start to get all the benefits of Quick and HTTP2, the fast handshake negotiation, et cetera. And you get a fairly secure pipe. Not fairly. You get a secure pipe all the way through to where your data is stored. So let's actually see how some of this works. So here I have an origin, which is a bucket of data. Can we switch to the demo? And here's the bucket. So the bucket is public. It's called public because the data in it is public. But the bucket itself is private. You cannot list it or sort of browse it. Here we have all the different objects that are that we will be serving. So these are all MP4 dash or MPEG dash chunks. And here you can see sort of the metadata for it, where at the object level I'm setting the cache control. So there I've said this is public, and its TTL is about 20 minutes. To the slides. So here you've seen the bucket, you've seen the chunks, and you saw how we set the metadata at the object level to mark it public with a certain cache value. So now let's actually set up this infrastructure and see what it looks like. So we'll be going back and forth between the demo and the slides for a bit. So let's create the Anycast IP that you just saw. So if I go to my VPC networks, and again, I'll just take one moment to highlight what this looks like in real life when you log into the console. You will see here it's one VPC, that's my default VPC, but it's got 10 .IP addresses in every single region, right? Which means if I need to send traffic from here to there, I don't really need to do any kind of transit link. I just go from one 10 address to another 10 address, and it just traverses. So that's sort of the whole global network and premium network and all those constructs that we were talking about. So let's go ahead and create one of those fancy IP addresses you were talking about. Reserve static IP address, and let's call this the demo CDN IP. We want the premium network, IPv4, that's fine, and we want a global global IP. So let's go ahead and click reserve. It's going to take a few seconds while it spins, and it's going to give us, after that, an IP address that we can use. Can we switch to the slides? Thanks. So we did that part, right? We figured out a way that an end client can look up an IP address and get to us. But we didn't create a DNS entry. So let's do that next. So here, our IP address is created. I have the address. Let's copy that. Let's go to our network services, Cloud DNS. And I have a CDN zone where, on a certain domain, I've sort of directed the name servers here. So I'll add a record set. And I'm going to give it, let's say, demo. And I'm going to put in the Anycast IP that we had captured. And we hit create. So here, I now have a DNS entry that maps to that IP address that we just created. Let's switch back. Cool. So our front end is kind of sort of done. Now let's create the load balancer. So the load balancer is going to do a couple of things. It's going to say, here's my front end. I want you to serve out of this IP address. We need to attach the SSL that represents that domain name that we just created. So let's do that. So here's in network services, here's my load balancer. Click. And let's create a load balancer. And of course, this is going to be an HTTPS load balancer. So let's click that, select start configuration. And we were going to do the front end. So here, let's call it demo CDN load balancer front end. We want HTTPS, and it's going to be using premium. And we created this IP address, so it's going to let us select that. Port 443. Now we need to attach the certificate. Where's that going to come from? So let's create a new one. So let's call it demo CDN LB SSL certificate. And here I can actually just select Google Managed. So I really don't have to figure out what was that OpenSSL command, or how do I create my CSR, and where do I send it, and those types of things. It makes it really easy to get an SSL up and running. Right? And so here's a managed SSL. I hit create, and that starts to create the certificate that will then get attached to my front-end load balancer. So here, I'm saying the SSL policy is default, and quick negotiation is automatic. So without really doing a lot, the front end will automatically try to detect how advanced your client is, and if it can support some of these more advanced protocols. And it will negotiate the fastest way to get a handshake going and establish a connection. So that's done. Let me switch. So far, we created the front end, and we attached the SSL to it. Now what we have to do is create the backend, right? So once the traffic arrives on that IP and SSL is negotiated, et cetera, the traffic has to go somewhere to get the data. Where does it go? We created that bucket. And so we're going to make that bucket a backend service that the load balancer will direct traffic to. And it could be a bucket, it could be a VM. You don't really have to, I mean, you can choose either one. In this, we're just using a bucket, so that makes it simpler. So switch to the demo. So here, in that same load balancer, let me actually give it a name. Demo CDN LB 1. So here's my backend. And I don't have any services attached. So let's create a backend bucket, which is specifically a serving bucket. And let's do demo CDN backend bucket, right? And select the bucket that we want, which is this one. Select. And again, if you recall, we had shown that simplicity, which is that checkbox right there. So once we click that, it will actually activate caching at the edge when this service becomes live on the load balancer. That's it. Create. So switch to the slides. Great. So we've stepped through that part, we stepped through that part, we stepped through that part, backend mapping to a bucket, and we actually activated caching. So we just have one other thing to do, is to say the URL map. The map is already done for us. It's a default map. It is to say, if I get like an HTTP path, where does it go? How do I send it somewhere? So there's already a default rule. If we switch, we can show what that looks like. So here in our host and path rules, you can see there's a default path that says anything unmatched will go to this demo bucket that we just created as a backend, right? So review and finalize. That's kind of what it looks like. And we hit create. So now this load balancer is getting created. What's happening as we speak in this process, if we switch to the slides, and let's go back one. What's happening now is, that the IP is getting propagated out, so this configuration is getting stood up. The SSL certificates are being replicated across the globe for serving at the edge, no matter where the traffic comes in. The configuration to map that backend service to this bucket is also getting pushed out. So really, right now, while that thing is spinning, we are getting a full edge deployment. So in our setup, we did a bunch of steps: Anycast DNS, load balancer frontend plus SSL, load balancer backend plus CDN, and the URL map to the content bucket. So now let's see what it actually looks like. So while it's getting pushed out, I'm of the Julia Childs school of technical demos. While the turkey's in the oven, we have a fully baked one for you, which looks a little bit like this. So this is a load balancer I had created earlier. This has already been pushed out, and everything is deployed. So if you see what that looks like, this is here. So here you have a custom subdomain on this content, which is getting served out. If you see what this maps to, this web/index.html, if you go here in the bucket, you have a web folder. And it's just a static website, this index.html, that's getting served out, right? So that's what you're seeing. So if we go back, you see that. And I'm going to start a video, which is getting served out of CDN. So I hit click. So this is MPEG dash. And let's see if I can make it smaller. So here, as the video is playing, you will see I'm using the browser performance API to capture the duration that it takes for the HTTP request to complete. Here you can see the MP4 files that we're retrieving for the 2-second segment length, and you can see the data size, right? So as the video plays, you have between 100 to 200 milliseconds round trip of retrieval for the full content. So let's then click that again. And here you see now, because the content is already cached, and if I play it, you can see here the duration has gone down to between 0 and 10 milliseconds, right? So, and you'll see the difference as soon as it hits the point where we stop the video and rewound it. The caching will continue. But again, it's a 2-second segment that the system has not seen before, but it's able to deliver it in a manner that you really don't have any drops. I actually ran this test from an airplane on airplane Wi-Fi, and I still got pretty much the same results between the 100 to 200 milliseconds average. So that was pretty good. I don't know if you've seen this video. This is one of the April Fool's videos we put out a couple of years ago. It's about self-driving bikes. It's very cool. Great. So can we switch to the slides? All right, so we took a look. So let's also visualize the network path, what that actually looks like. Because Brian talked a little bit about the premium network and the standard network and what the path things take. So I will actually want to show you what you just saw, what the network path or something like that would be. So if we can switch to the demo again. Here's sort of the exploration of Google's network. So let's begin. And it's telling us about standard versus regular. So let's take a look at what public looks like. If our origin is in Oregon, and we want to be somewhere out here, and we hit go, traffic will egress from Oregon. It'll bounce around. It takes a nice leisurely stroll through Canada, and finally lands where you actually want to see content. And when you're traversing the standard network or any other sort of generic cloud provider network, this is sort of what you get. And which means if your CDN is like that, that's kind of what you're going to get too. In fact, the reason CDNs were built was because this was happening. That's why you needed something very close to actually send that traffic to this person, which then also meant that you have constructs such as pre-warming, pre-caching, et cetera, et cetera. But when you switch to the premium network, a lot of those constructs really start to get redefined. Because what happens is you do take that direct path to the closest POP, and then you have a very short public transit path. And milliseconds count, right? If you look at the speed of light, each millisecond is about 186 miles of transit. So if you're shaving milliseconds off in this transit, it allows that single POP to serve a much wider radius, right? So when you do that sort of optimal curve math and all that, you start to get some very interesting results, and you start to really rethink how you think of CDNs, not just in terms of how many nodes do you have, but really what's behind those nodes. How are they actually establishing connections? How are they getting their data? How are they connecting with ISPs and so forth? Let's switch to the slides. One interesting thing is also talking about Anycast. So I started using GCP back in 2009. I started with App Engine. Thank you very much. I was actually a customer at some point. And that was all I knew. Like, hey, this is how it's supposed to work. Why would you do it any other way? But Anycast really makes it super easy because you get from where you are to where you want to go, generally in a single hop or very close to a single hop. And you can compare that to access over a regional external IP address. And again, we saw how simple it was. We just created a single DNS entry, and all our traffic could flow through that distributed infrastructure. So we'll take a look at how Anycast actually works. And this is not necessarily CDN, but it's actually showing if you do a trace route from, let's say, a network, a VM on a standard network in, let's say, Frankfurt, if you do the MTR on that load balancer IP, you will hit that endpoint in essentially a single hop. My content is in the States, but it will still get served out of this infrastructure, which is a single hop away from that user in Frankfurt. If you look at non-Anycast transit, which means the Frankfurt VM has to leverage a standard network, bounce around the internet, and go to LA, you will have a lot of hops in the middle before you actually get there. Right? And if you start to add up the milliseconds and all the extra transit time, it really makes a difference. And of course, it was easy to set up, so we saw that already. The other thing that the CDN does is automatic optimization. So whether it's 1 byte or 5 terabytes, we can handle objects anywhere in that range. And we will automatically optimize whether we should put it in SSD or HDD. So you don't really have to say, this URL map, because it has videos, please put that in HDD. This has smaller images, please put that in SSD. We'll just sort of see the content length headers, et cetera. We'll figure all that out, and it'll be done. The content chunking is also handled automatically. So, which means if we get a byte range request, we will translate that byte range request into the chunk requests that we need. We will go get those chunks, cache them appropriately, see what we have already from an internal manifest, and then serve the correct stitched together byte range request out. So if your byte range is spanning 2 chunks, we will take care of that implicitly. Like there's really no extra configuration or manipulation you have to do. So let's talk a little bit about security. For that, I'm going to hand it over to Brian.
So let's talk about how we think about security at Google. First of all, we have always believed that the internet should be SSL, right? And so we kind of start everything here with no-cost SSL, right? That shouldn't be a feature you pay for. Your site should be secure. That's the way the internet should be. We make it easy for you to make new certs with Google Managed Certs, and everything's encrypted from our GFEs, from our front end, all the way to your back end, right? So you know that there's an end-to-end encrypted experience. We offer signed URLs, which help you secure your content so that you can make sure which requests are allowed to be there. You can generate your signed URLs offline with GCP, with custom keys or with keys that we provide. And we can actually do that, say, in the case of live video or in the case of chunked video in the manifest to every chunk request. And the signature is validated right at the CDN edge, right? So if there's kind of requests that shouldn't get through, they'll get blocked right where they started. You can see what that looks like in the context of Saurabh's demo, right? We've actually signed every chunk right in the manifest file. And that's pretty easy to do. We have kind of example code linked to here. And again, that's all going to be checked right where it happened. Let's talk a little bit about DOS attacks and DOS defense. So we have a product called Cloud Armor that helps you, that you can use with CDN, that helps you to write more complex rules and to be able to block DOS attacks where they start. But at the end of the day, to even get that far, you need to make sure that you have an infrastructure that's scaled up and ready to handle the scale of attacks that we see on the internet today. So step one of kind of DOS prevention at Google is to outscale the attack, right? And that's where making sure that you ride along with a provider who has enormous scale is a really important consideration. And we have a great quote here from Damien, one of the folks that looks at DOS at Google, basically saying that absorbing the largest attacks actually requires the bandwidth needed to watch 500,000 YouTube videos at the same time at HD. And we don't see that trend slowing at all. If anything, we see the scale of DOS attacks at Google sort of hockey sticking, and that's the thing that we've been planning for in our products and in our infrastructure. And this is just an example of kind of what that looks like in your project. So we ran an experiment just to see, can we sustain a million QPS DOS attack on an example project in a load balancer in GCLB. And you can kind of see that through the entire duration of the attack, everything kind of stays running smooth and steady. And then I think the other thing that's worth talking about is that because we have this global network and because all of your cloud IPs are going to be Anycasted, that actually makes it very hard to concentrate a DOS attack on any particular element of the Google infrastructure, right? So the DOS attack will actually get absorbed across our entire peering surface all across the world, where it'll be handled and dealt with there. And so again, I think what that means is that you know that when you come to Google, you have an infrastructure that's built to ride out some of the biggest attacks that we know about today. I'll hand it back to Saurabh to just talk about how to put this all together.
Cool. So, winning, right? Making it work for you. We give you ease of use, all of Google distributed infrastructure and serving capability delivered through a single checkbox. It gives you the Anycast IP, the content services, the monitoring and logging, programmatic control, everything is done through an API, so you can script out all the work that we just showed through a user interface. The scale, of course, is billions of users. If you look at, again, the next most utilized services, they do not have the same order of magnitude of scale that we routinely work at. The critical thing here is ramp without warm-up. So if you have content, if you have any type of end streaming system and you do not know what demand is going to be, it's very hard to kind of get the right provisioning up front. But with Cloud CDN, you really don't have to worry about that. The scale will just be transparent and automatic. Again, footprint. So it's not just how many can we serve, but where all can we serve it. And again, the most popular sites all across the world, some of them, like the Google ones, they all leverage this infrastructure, and you get to ride the same underlying stack. And of course, there's security. So it's not any good if you can't protect your content and your infrastructure. So you do get all the investments that we make. You just get that out of the box. So it's the outscaling of attacks, the Anycast sort of distribution, and the free SSL.